Hey everyone, welcome to my channel. Let's continue our prep with Databricks Spark Developer certification thing. So there is a provided training I already explained in the last session. So yeah, the Databricks they created a some learning quest, so where you can participate and you can just try to learn those skills. Um, so let's continue in that. I mean, we are aiming for the Apache Spark Developer Certification. We already completed introduction to Apache Spark in the last session. We'll continue with this developing applications with Apache Spark. So let's continue in this session. So course introduction video will be there, and after that, before getting start, some information, basic information we will be having about this session. Let's watch that information. Mm, like this, yeah, Databricks, highly innovative company. So you can submit your feedback once you attend this session. Next, course summary, and let's developing using Apache Spark, and there is DataFrame API basics. So let's continue with the slides. So we're gonna deal with only slides in this entire video, entire session. So let's continue with that. Let me go back to the third slide. Second slide will be the course overview. So let's continue with that. Okay, so data frame transformation methods. So data frame operations are distributed automatically across all partitions, enabling parallel processing in larger datasets that we already aware. Best parallel processing engine as so far is Apache Spark. So all data frame transaction transformations have equivalent SQL operations under the hood. Of course, select will map to this. So regarding the Databricks API, the basic information it has given. Methods return a new data frame rather than existing data frame. This is what we learned in the last session as well. And of course, the corresponding operations it has given. I think this is briefly reviewing to the previous session. I think handling missing values. So to handle missing values, we have few methods we need to apply, um, which are these. And let's continue. And second, I think I'm at the wrong place. Okay, just giving an overview of the last session, like the similar things. These are things repeat in this introduction thing as well, but still they are giving here as well to go into little deeper. Just we can just go through those things, and after that we can continue. So let's think about built-in functions. So functions operate on columns in data frame. Functions can operate on scalar. Of course, these are the two types. This is also covered in the last session. So round, concat, the similar corresponding equivalent um, SQL functions are given here. Coil is, I think we need to literally remember this, like first nominal value in this coil is function level. It is like that. And if you go to the Spark level, there is one more coil is called repartitioning of, reduce the partitions without shuffle. That is the basic difference we need to remember. Apart from that, user defined functions, you need not to use that thing. Okay, let's continue. So this is what the basics are about, and API basics they have given. And this is the video basic ETL operations from the Databricks API perspective in the Databricks environment. It will provide the video of this. And if I so practical implementation of the operations, it is shown in this. You just directly do it in the Databricks website itself, but I'll just explain the slides just to get a brief simple overview of the course, so that we can proceed further. So let's continue. I think these are the slides. We'll retake this lesson, and let's see. Let's go to slide number 3. Okay. Next, grouping operations it has mentioned. So grouping operations in Spark operations data across nodes based on grouping columns. Aggregation execute parallel across partitions for optimal performance. Similar to SQL group by, but with more flexible options. Supports multiple columns for complex grouping patterns. Complex grouping patterns also it will support. Group by returns a group data object that lets you chain aggregation methods like count, sum, average, and something like that. Some aggregation methods. This is also lazy evaluation until the action triggers, of course. Group by example. As we already discussed in the Spark session, we included in another playlist. So, group by department, department and location, and average of salary. Group by column operations and year of so and so. These column operations can be performed as well. Mm, in that, and of course, in there is a difference here, like department directly used here and column of department. Um, and year, hire date, and in that from that it will get the year and it will column department value, and the sum of revenue, something like that, based on the aggregation method I'm using. So using column expressions, multi-column grouping, like here one column grouping here is specified, and here two columns like department and location needs to continue the average, calculate the average salary. That's what it mentioned. Next, some methods, basic aggregation methods we can see here. Count is count in SQL environment. Sum, average, min, max. It's almost same as the SQL method. So if you are already aware of the SQL, I think you will be able to pick up this easily. So combination of multiple aggregations. So let's continue this. Okay. So combining multiple aggregations can be performed on the same grouped data set using aggregated functions. Like for example, I am giving group by department, and that I want to aggregate first sum of salary alias as a salary, total salary name we need to use alias sum of salary. It calculates the sum aggregating, and comma another aggregation you can use, like average of age alias average age, something like that. It can be grouped together. Alternate syntax for the same is aggregation of double, in the flower brackets you need to mention salary sum, uh, age average, something like that. So it can be aggregated, can be used with Panda UDF as well. Of course, Panda UDF I can be using. Uh, Aggregation is also needed for aliasing as single aggregation function. 1 minute. Let's read out here. The different aggregation methods that you can use with the grouped data object allow combining multiple aggregations using the aggregation method. For example, DF group by department. This is it's they are explaining just about the combining the two different things here, two different aggregations together. Okay, you can also format this as a dictionary using keyword sum and average. So if you know these type of keywords here, the dictionary it is specified in the aggregation. Key value pair, I mean salary sum, age is average. That's the way you can mention that. So that's what they given. Next, window functions. Window function introduction, like aggregation without losing row level details. If you aggregate, that will be grouped. So if you don't want to group and you want to add additional column and whatever the aggregated value you want to specify there, that thing can be achieved using a window function. What are them is special functions that perform calculations. Just a second, I'll be back. Yeah, sorry for the break. Yeah, let's continue. Yeah, when to use calculating running totals, average, ranking, accessing previous next row values, comparing row values in group aggregate. So in these cases, you need to use this. Okay, let's continue. Window example, like you need to specify the window with partition by and order by. So on top of that, you need to apply over with using the over key. Like for example, in this case, specification is like, you need to import those libraries, window import in window, and functions, all functions we need to import. It's a better way to import. Instead of specific functions also you can improve, depends on your situation. Okay, window spec equals to window dot partition by department order by salary using window functions df with column rank. You want to apply rank function. You need to apply over window spec, whatever the spec you have created. It's like a table. On top of the table you are applying rank. So the same way remaining everything, some like, okay, all those things we can apply. So this is done. Let's go to the next lesson. This demo is here. I mean, you can just go through that later. The description, in the description I have given the link for this. You can navigate to that and you can learn this. Just you need to create the user ID. Let's go through the next set of slides. And it'll go into little complex operations like joins and all. So let's see that. Join operations, data frame join operations, understand how to combine data from multiple data frames. I think joins you already aware, I believe. So join combine two data frames based on matching key values. Of course, multiple join types supported: inner, outer, left, right, cross. Inner, outer, left, right, cross. These are the join types. Join condition can be used singular, multiple columns, multiple keys. You can use one key, multiple key. Column naming conflicts handled with data frame aliases. Alias names you can specify, and you can handle the column name issues. Like if the column name is not matching, you can use alias and you can match it to the existing key, and you can exclusively mention that key value as well, so that it can join. So join example is here df1 df2 is user id, default is inner join actually. So that's why user id is a common key in df1 and df2. That's why you just need to mention one key. It's a straightforward basic join example. But if you want to specify join type, join df2 on df1.userid equals to df2.userid comma how equals to left. Instead of on equals to how equals to, you can remove that directly. You can just df2 comma df1.userid, of course user id from the df1 column, and df2 left means left join. It is left to whatever the values that are there from df1 will be there, and the corresponding matching values from the df2 will be available in the target. Multiple conditions with data frame aliases. So yeah, let's specify that as well. Users dot alias u dot join. So we are mentioning users as u, orders as o in alias methods. Join key we have mentioned here, and in that, in the brackets we mentioned the key column operation on u.id means users.id equals to column o.userid, because I in this users it is mentioned as id, and orders it is mentioned as user id. So that both needs to be matched together, that column operation like this. And it's the same way region as well, u.region and o.region is matching. The join type we need to mention as inner join. So something like that we can mention to have a better understanding. So next, set operations. Let's see the set operations. Understand relationship within datasets. 1, 2, 3, 2, 3, 4 is an example given. A, B union includes all unique elements. Sets will be with all the unique values. It cannot be duplicates. So set operations will be like that. So no duplicates. A U B, A union B, A intersection B here. Only the values that are common together. So those things will be specified here. Subtraction means A minus B means you need to remove elements that are there in B from A. So 2, 3 is there. That's why it is removed and that's given the value. This is the set operations. Next, data frame set operations. So let's see what are those. So union, intersection, subtract, and union by name. Union by name. So union means combine all rows from both data frames by position. Only by position, union. Intersect returns only rows present in both data frames. Subtract returns rows in first data frame but not in second. Okay, A minus B means A is the first data frame. So A minus B. So not in second, remove the second. So that's why subtract. Union by name. Instead of combining the union, they both are the functionality is the same, but the thing is here it is combined by this by the position of the column, but here column names it will match. So position by union by name will be matching by column names. Default set operations remove duplicates. Of course, obviously, default set operations are set itself is um, should not contain duplicates. Okay, this is next. Join performance considerations. Okay, optimize relational operations in distributed environment. Join strategy selection. More selection is more info. Strategy is definitely what type of join you need. What are all the keys? That is the main area we need to focus on initially before doing the join. Which is a small data set, which is the big data set. Also the size of the data set also important, because Spark internally applies broadcast as the thing that it internally applies that, but in you exclusively specify broadcast, then the small data sets will be copied to the corresponding partition, right? Each partition have that particular data set, whatever it is mentioned in the broadcast. For example, in this case, since you mentioned broadcast small df, this small df will be placed in each and every partition. So the join will be very easy. The large data set partition, one of the partition of the large data set will be in that particular area, and it will match with the corresponding data set. So that's the best way of doing a join. Next, minor join considerations. Just a minute. Data skew. Yeah. So data skew is like, based on the key values, when you submit join, based on the key values, the partition will be happening. Each key will go a certain partition. In those cases, what happens is, if a particular join key value has n number of records, more number of records, then one partition will be huge and other partition will be less. In that stage, you need to do a memory management. That's the best thing you need to do. So data skew. So that there it's called a data skew, because that one, okay, uneven distribution of join keys can impact performance. Consider repartitioning in some cases. Memory management. Monitor shuffle spill matrix for joins. Shuffle spill matrix is like, uh, based on the data, how much shuffle can be possible. That thing you need to have a good idea. So they that with that you can able to understand what can be done in the spill matrix area. So okay, consider caching frequently joined data frames, so that avoid the multiple times of joins. Like for example, if a joint database is there, you didn't cache that to the memory, you didn't cache that to the disk, you need to do join again, which is a costly operation. Instead of even though it is spilling to the disk or retrieving from the disk is a little bit easy, little bit less cost compared to joining again. So those cases you try to cache them. So use projection to select only needed columns, of course. Minimize the list of columns which is needed only, whatever it is needed only, then you do it. Okay, let's see. Data skew handling. Uneven distribution of join keys can impact performance. Consider repartitioning. In some cases, repartitioning can be done, repartition function, and also coalesce. Coalesce do repartition without shuffling. Repartition will give whatever the number of specified partitions it will give, but it will do shuffle. When you want to decrease the partitions, use coalesce. And if you want to do increase or decrease, then you use repartition. But you need not to worry about shuffle cast, then only do repartition, otherwise do shuffle only, do coalesce only. Okay, this is done. I think next session, next thing will be it. So the similar, whatever the operations that are specified here, that will be discussed in this video. Then you can just go through that. Then let's go ahead with the next slide show, which is a complex data. Let's restart this session. Complex data types in Spark, which is arrays, struct, and maps. Okay, complex data types are common in modern data pipelines, especially when working with JSON data. Nested analytics results or feature engineering type includes arrays, structs, and maps. PySpark.sql.types.array type, ordered collection of elements. Okay, struct is like a structure type, and it nested structure with predefined named fields. So when you define the schema for a particular thing, you use struct type, and in that you mention the structure of each and every element, each and every column details. Okay, that's the struct type. And another thing is map type is a key value where keys are not predefined. Okay, so this is three complex types of are there in the. Okay, join strings versus structs. This is a good thing. Join strings require parsing overhead and memory waste. Okay, if you're using, okay, user ID and features. If you map string join and JSON strings versus structs. I'm so sorry. JSON strings require parsing overhead and memory waste. Structs give type safety and better performance. Convert early using from JSON with schema. From JSON column. Okay, this is a JSON structure here. Define schema matching JSON structure. This is a JSON structure. Struct type, just now I said like schema equals to struct type of JSON field, like struct field, so and so field name and long type. So convert JSON strings to struct type. So from JSON with column parsed from JSON will help you to get the schema end to end. So that's the best way of using it. Just it's a mechanism of how to use that. Next, working with struct types. Working with struct type in DataFrame, struct types maintain a logical grouping of related fields like a table. Yeah, structured. Okay. Struct fields can be accessed and operated on using dot notation or using get field. You want to access that particular field, then you can just use dot get field to get that particular value. Okay, 1 minute. column username, direct field access. Next is alternate field access, user dot get field age. So next column user dot stores of 0 means it's a zero indexed alias first score. So nested access. So here the zeroth element will be considered here in the username user. In that there is a user dot score. There is specific notation. It is given here. I mean you can use different ways to do the struct types in Spark. Explode function. Okay, explode. What is explode? I forgot actually. 1 minute. Unnesting nested data. Okay, if a data is nested inside and you wanna unnest them, explode function will be helpful. That's a good thing. Alias item, explode items, and alias item. So I think it's a vector format and it made it as a scalar. So I think rows to columns it is differentiated. So id item 1 1 1 1 1 also is a simple explode. New row per array element, each element it will be a new row. Okay, got it. So next, common array column operations. Let's see the operations what are all there in the array level. common functions are Common functions for array column manipulation. Just a second, I'll be back. Yeah, welcome back. So some functions in the array contains tests if array contains specific value or not. Items a in that array contains a or not, it will return I think true or false, I believe. Yeah. Size of the column, it returns the number of elements in the column. Can you hear me right? Yeah. So number of elements in the column, element at, I mean index of the element, I believe. Yeah, it will return the nth element. Okay. Return the nth element. Hmm. Array distinct means deduplicate removes from the column. Yeah, that's a good thing. Next, aggregating two collections, collect list. Let's see what is collect list here. Collect list is an aggregate function that gathers all values from a column into an array, commonly used with group by. Group by region, aggregate, collect list, alias, all products. List of products will be there in that. It is making it as a vector form. Okay, now it's good. Build arrays, related values within each group. Collects it. Works similarly but removes duplicates, producing arrays of unique values. Collect set. Whenever it comes set is a unique value. Simple. Array list is all the values. Array set is unique values. Sorry. Collect list is all the values. Collect set is unique values. Okay, best practices for complex data types. Consideration when working with nested structure. Explode on large arrays can be cause data explosion. One row becomes n rows, which can overwhelm memory and processing. Of course, we need to know the. If you understand the functionality of the function, you may be able to understand how it works. Okay. Next, collect list, collect set can be memory intensive when groups are large as they hold all values per group in memory. That's correct. Collect set, collect list. Consider collect set when deduplicates aren't needed and the order doesn't matter. Okay, it irrespective of the order, it will just combine all those things. Uses less memory because it removes duplicates. Less shuffle overhead as duplicate values don't need to be collected. That's a very good thing. I think this lesson is completed. Corresponding demo is here, and of course the entire course is completed in this. And let's go to the quiz. I already scored it, and let me test it. Let me see the answers here. 20 questions are there. Okay. When working with arrays and structs in complex data types, what is the correct approach to extract nested values from struct column while maintaining optimal query performance? UDFs manually pass, explode struct into separate rows. That will be a memory explosion. Convert the convert the struct to JSON string first, then parse individual fields. Use dot notation column struct column dot field name or get field method to directly access nested fields. Instead of exploding everything, you just go to the nested fields. Okay, that's correct. Leveraging Spark's columnar storage optimization. That's the best way. When working with complex data types in Spark, what is the fundamental difference between using explode and pivot functions in terms of data transformation and performance implementation? Explode transforms array map columns into multiple rows, increasing row count, while pivot transforms row data into columns. Pivot is row into columns. Explode array data into scalar format. That's correct. In time-based analysis using aggregations with window functions, what is the key consideration when defining window specification for calculating moving averages over time ordered data? In time-based analysis using aggregations with window function, what is the key consideration when defining window specification for calculating moving average over time ordered data? The window specific must inquire proper partition by, order by, and frame boundaries, row between, range between, to ensure correct calculation of moving averages over the intended time period. Okay, if it is not ordered by time period, then obviously you cannot able to do anything here. I think this is the correct answer. To optimize memory management during complex joins, especially when dealing with very wide transforms, what crucial preparatory step should be taken before smaller data frame? Smaller data frame to DataFrame to reduce realization? No, this is wrong. Monitor shuffle spoil matrix. Shuffle spill matrix in the Spark UI. Memory management during complex joins, especially when dealing with very wide data frames. What is a crucial preparatory step should be taken before executing the join? Convert the smaller data frames to RDD. Data frame to RDD format? No. Cache all involved data frames persistently to disk storage? No. The projection to select only needed columns. This is the third one. That is wrong I gave. See, project only use projection columns. Yeah, correct. That's correct. When extending Spark with custom logic, developers can define user-defined functions (UDFs). What specific architectural limitation causes standard Python UDFs to? Okay, there is a okay. I can do that. Python UDFs are executed only on the cluster driver node, eliminating parallel processing. No, this is wrong. This is they cannot be optimized by the crystal optimizer and have serialized overhead. This is the correct answer. Yeah. A data engineer needs to calculate the average trip fare, the total number of trips, and the maximum distance for each distinct lookup, distinct pickup location in invasive taxi dataset. This is a dataset example given in this particular training. Okay, which specific data frame method must be utilized after group by to apply the combining these multiple aggregation functions. Aggregation. The explode function is critical for unnesting array elements into separate records. When applying explode to an array column, what major performance risk must be actively monitored by the data engineer? Data explosion is the main issue because one create a number of rows. That's the correct answer. A join is being performed between a large fact table and a small dimension table under 100 MB broadcast. Large table, small table, broadcast is the best. Okay. Data frame transformations are core to Spark ETL pipelines. What is fundamental concept to ensure that these operations support immutable transformations in distributed environment? Method return a new data frame rather than modifying an existing one. When using window functions for advanced analytics in grouping and aggregation operations, what is the key advantage of using window functions over traditional group by aggregations for calculating running totals and rankings? Window functions can compute aggregate values over a specified range of rows related to the current row without collapsing the result set. Group by will return one record for each group, but whereas this window will have all the records available, preventing individual row details while adding analytical metrics. So that is the best. First one is the correct answer. In Spark set operations, two data frames df1 df2 are guaranteed to require matching schemas. Which method is used to return only those rows that exist in the first data frame? Which method is used to return only those rows that exist in first data frame but not but do not exist in the second data frame? Left anti-join. No, subtract. Left. Okay, subtract. Method. Subtract method. If it is a join, it will be left anti-join like df1 join df2. If that is the case, left, if you do join type as left anti-join, the values all that are matching with df2 will be returned which are there in df1. Okay, then subtract is the correct. Okay. So here it's a method. It's not in asking about the join type. Spark operation, two data frames are guaranteed to require matching schemas. Which method used to run here? It is not exactly a join type. It's just method you can use from the DF2 easily without joining. It's a set operation. Set operation. Join itself is not a set operation here. Just two data frames will be joined here in this case. Window functions are used for advanced analytics like ranking or calculating running totals. What is the unique characteristic of window function that fundamentally differentiate it from a group by? It performs columns across a defined set of rows related to the current row without losing low level details. Correct. Group by will have only the unique one record will come out of each group. When using collect list and pivot functions together for reshaping e-commerce data, what is the most important consideration regarding memory usage and data distribution? This is an important question. Collect list aggregates values into arrays, which can cause memory issues with large groups, while pivot creates wide tables that may impact performance. Both require careful consideration of data cardinality and group size. Correct. When converting JSON string data to Spark SQL native complex types, what is the most efficient approach to handle schema inference and type safety? Struct type. Struct type and struct field is the best thing because it needs to specify everything. Correct. Which statement about data frame operations in Spark is correct? They are executed immediately upon definition. No. They modify the existing data frame directly. No. They are distributed automatically across partitions. Yes. They cannot be mapped to SQL operations. No. So this is correct. In the context of ETL operations with the data frame API, what is the primary performance consideration when deciding between using user defined functions versus built-in Spark Catalyst Optimizer and Tungsten Execution Engine? Catalyst Optimizer with help of Tungsten Execution Engine for better performance, while UDFs require serialization overhead and cannot benefit from code generation optimization. Which example correctly combines multiple aggregations on a grouped data frame? Group by DVD aggregation, salary sum, average age AVG. This is also one possibility is there. Sum of salary, this is not. This is a correct. Another representation is there. You need to specify column salary dot alias, so and so alias name, comma, average age dot alias of alias name. That way also we can mention. When aggregating data into collections, the collect set collect list methods are used. If duplicate values are not needed in the resulting array, y is y is using collect set the preferred best practice over collect list. Collect list will just combine and keep everything, but collect set remove duplicates. Yeah, remove duplicates. That's correct. A raw data frame contains nested data stored as JSON strings. What is the primary performance and governance benefit of using the from JSON function? A row a raw data frame contains nested data stored as JSON strings. What is the primary performance data governance and governance benefit of using from JSON function with a preferred schema convert these JSON strings to struct type. Struct type enable columnar storage optimization and better query performance via predicate pushdown. That's correct. Predicate pushdown is done by capital catalyst using tungsten. When performing group by operations with multiple aggregations in Spark, what is the most efficient approach to compute different aggregate functions on same group of data while minimizing computational overhead? Use single group by operation with multiple aggregation functions chained together. Yeah, that's correct. Once it is grouped and that set of the data is ready to perform aggregation, so combine all the aggregations together. Yeah, that's it for this window. Back to the course. Everything is done in this course, and let's go back. Let's move back to the next course in the next session. Thank you so much. Next session is structured streaming, and